Hello everyone, so in this video let us talk about 3 problems from the Leetcode Biweekly contest 83. So let's start. The first problem is best poker hand. So the problem statement goes like this, that you're given an integer array ranks as well as a character array suits. So as you can see, an rank array as well as a suit array. Now you have 5 cards in that. So you can denote like 5 cards. Now the ith card has some rank as well as a suit. So you have seen that they are, when you play a poker, you have 5 cards, okay, and every card has some number on it and the type of the card, let's say like heart or something like that. So they have denoted by suits and the value of that is denoted by rank. Now when you have a poker hand, it has some ranks, okay, like what is the best hand, what is the least hand, and so on. So they have denoted 4 type of hands. The best hand is a flush, in which all the 5 cards what you have the same suit, okay, that's the best possible hand that you can get. The second one is 3 of a kind, in which 3 cards are of the same rank. The pair is 2 cards of the same rank, so 2 cards are of the same number, as well as high card is any single card. Now you're given this as an input, the ranks and the suit, that is the 5 cards, and you have to tell me that what is the best hand you can get from these cards. That's the overall thing. Now in these type of problems, when you have different scenarios to test, I highly recommend you to make separate functions out for each of these following processes. By process, I mean that if you want to just check out whether a particular deck, or not deck, like the particular cards you have gives and like it satisfies the condition for flush, don't write everything in the same function. Just make separate functions and call those functions from the main function, so that reusability of the code is also done. And that actually helps you for interviews also. If you give different interviews, and this is very importantly seen. So I'd like to move from the code so that, because it is not much to be like drawn out. So what we have done is that I have made 4, or not actually 4, the last one is intuitive. So 3 functions. The first one is that I'll first check, because for the cards I'll just check whether it is giving us a flush. So is flush, in which I'll only test the suits, like if they all are same. So is 3 of a kind, in which I'll send the ranks. Is pair, also send the ranks, and if none of them is satisfied, then it is a high card. Fine. Now how I'll check that? I have made separate functions, because as you can see now this function looks more clean, and you can also read the code out how it becomes like anyone can read out very easily. We are checking out these 4 conditions, and for checking out is flush I have a separate function, not everything is mugged up in the same function. Good. So is flush function will just check that all the suits are same. So just iterate over from the second suit till the end suit and just check it with the first suit, like first character or like the first card type. And then if everyone is same, then it's a flush. It's 3 of a kind is that you can, like, there are multiple ways, but you can make a small map and insert all the rankings in a map, so that we have a count of every ranks we have. And if any number, or like if any rank is greater than or equal to 3, because greater than or equal to 3 means that it has at least 3, so I can give that it is a 3 of a kind. If it is greater than or equal to, it's like a pair, or else like you have the high card. That's the overall logic and good part for the first problem. So moving on to the second problem. The second is number of 0 filled subarrays. So the problem statement goes like this, that you're given an integer array nums, return the number of subarrays filled with zeros. So different type of subarrays you can extract out from this array that are all zeros. Now you have to solve this out. For this problem, let us take the first example so that it will become more intuitive to you. It is very simple and very standard problem. So 1300, 1300, and then 2004, so 2004. So because you have to find a different type of subarrays, then you tell me what are different subarrays for this example only, so that you will understand what is the problem is actually asking. So one subarray is this, one subarray is this, one subarray is this complete, one subarray is this, one subarray is this, one subarray is this complete. So there's 6 subarrays. By subarray means that you can take out a chunk, okay, a different chunks, like different type of chunks in which everyone is 0. So I can take out this chunk, like only this chunk, 1 0, everything is 0. This chunk, this chunk, this chunk, and so on. So there's 6 chunks, and the answer is actually 6 only. So yes, 6. Okay. So I hope you understand like what is different type of chunks. So like instead of counting out every different chunk, you can do this in O of n square also, but the time complexity doesn't permit that. So best, like what is the next best way is that find out the biggest chunk you can get. Okay, you can just find out what is the biggest chunks you can get, and from those biggest chunks you can directly intuitively get how many smaller chunks you can get. So let's say that I have a very big chunk of zeros, 1 2 3 4 5 6 and so on. Let's say 6 only, and how many smaller chunks I can take out from that. So I will take out a chunk as a window, as you can see that some window. So starting from any point and ending at any point. Okay, so what you can directly see is for the first position, I have to close the window at 1, 2, 3, 4, 5 points. So if I start from the very first point, I have 5 position to close the window, like this. So it's like 5. Then when I start from the window from this point, I have 4 position, 1, 2, 3, 4. So 5. So first I have 5 windows, then 4 windows, and 3 windows, starting from every ith point. So total windows, the total sub arrays I can get from the very big sub array is like 5 plus 4 plus 3, 2, and so on. So it is like total sum of all the numbers, that is n into n plus 1 divided by 2. Right? So I have different type of sub arrays which I get. So 1, 2, 3, 4, 5, 6. So I have 6 actually, not 5, 6 type of windows from the very first position, then 6 and 5, then 4 and 2 and 1. So summation of all of that turns out to be like the formula is this, n into n plus 1 divided by 2. It's a very standard problem. So the main consensus, like the main things which boils down to is that you can find out very continuous long windows of 0, and when you have the length, let's say it's n1, this is n2, then the total number of sub arrays I can get from the very long window of n1 size is n1 into n1 plus 1 divided by 2. Similarly for n2 as well, and just add everything out while you making out this window. So you can just iterate over this whole array from left to right in O of n, start out and finding out what is the longest zeros window you can form, and then for every 0 window just use this formula to get out the answer. That's our logic for this problem. So I have pushed -1 in the end. Why, I'll tell you in the code part later on, but yeah, this is total, how many total sub arrays I can form. This is count, like count is how many zeros I have seen, like the continuous strip. So I'll iterate over this array. If whenever I see a 0, which means that I will keep on building total. So total, so now here total is key. Like total, now this is count, is not actually the count, is the total count of total number of sub arrays I can get. So total will show how many continuous zeros I have. So continuous zeros will be stored in total. Whenever I keep on seeing 0, I'll increment my total count. But whenever I not see a 0, which means that now I have continuous 0 window, I will do count plus total in total plus 1 divided by 2, and then make my total again 0, because now I have to again start afresh because this window is terminated. Now what you can see that I will only make this total 0, and I will only count this when I see a non-zero number, because at that point I know that my window is completed. But in the end, maybe there is a case in which there is like the array is like this 1 3 0 0 0 0. So I will keep on counting zeros, and I will go out of, like I will just run out of this for loop, and I will not add the answer. So in the end, either you will write one more if condition and check that I have some count, I have some window, but I have not included in the answer, so I will include an enter count like separately, or you can explicitly add a number that is not inside this array, because it is so all the numbers are positive, so just I inserted a negative number. Okay, or so num_suffi can be like a negative also, so you can insert any number. Okay, you can insert any number, and in that case, whenever like this number will hit like very negative number, 10 to the power 9 minus 5, you can also add whatever you can insert that is not inside this case, and that scenario what will happen is it will not hit that number, and you will get your answer. Okay, that's the overall thing, so that it will eventually always hit in this else condition, and you will get the answer. You don't have to run one more else condition. Move on to the last problem in this video. So design a number container system, in which you have to design a number container system that do the following 2 operations. The first is insert or replace a number at any given index in a system. Okay, so you have different indexes, you have to insert or replace numbers from those given containers. You can assume that different containers, and you can insert number or replace number from that container. Similarly, the next thing is return the smallest index for a given number to be present inside the system. So you can just assume different lockers. Okay, I'll just give you an example. Let's say there are different lockers for you. 1 locker, 2 locker. They're side by side. Okay. Now one person puts, let's say, 10 here. You can just assume that put 10 number here. Then some person again put 10 here. One person put 9 here. One person put let's say 9 here, 7 here, and so on. Okay. Now they can also update this. So let's say maybe next time they put, let's say, 9 here. Okay. So let's say for the first case, this is 10 here. Okay. Now you have to update this in the containers or lockers, and you have to also solve a query in which I have to give like what is the smallest index. So these are index from like 0, 1, or not 0, I think so 1 index, I think so. So 1, 2, 3, 4, 5, 6. Okay, what is the smallest index at which a given number is present? So 10 is, let's say, what is the smallest index where 10 is present? So 10 is present here as well as here as well. So smallest index it is present in 2. Okay, but you can also update it. Maybe in the next iteration you change this number to, let's say, 8. And then now if you again do a query of where is the smallest index where 10 is present, then the answer is this. I hope you get the point. So you have to dynamically update these values in the container as well as give the answer of where the smallest index of a particular number is present. Fine, that's the overall problem. Now how you can solve out this problem? So the main problem is like for the main, like this problem has the main constraint is that you have to do query on the number itself. Okay, so in such a problem, always think that what is the thing you have to do query on. Okay, and store that particular, like try to store your data in that particular order only. I mean is that I have to do query on numbers. So instead of making containers, why not store the data for numbers, like for a particular number where in which containers it is stored. I hope you get the point. So like instead of making containers and storing that this is 10 is present here, 10 is present here, instead of taking that, why not just make a system in which I have a mapping in which, let's say, I want to store where is 10 is present. So 10 is present in container 1, container 3, container 5 and so on. Or 2 is present at no containers. 5 is present at, let's say, 4th container. Got the point? And now you can make this part, because I'm storing out what is the container, like in which containers that is present, container index. I want to get the, so I can easily store it out. That is fine. So I can directly like use this type of structure. Now if the first thing is I want to insert or delete it. Okay, and insert and delete, I can make it fast by making this part a set in C++, or you can make, like you have to do query very fast on this part. So what I can do is I can make a set here. I can use a set to store this data, like where 10 is stored, the container list I will make a set, because okay, by set I mean like what all the indexes are stored. Now I can easily do an O of n query to update those values, delete this out easily. And if I want to get what is the smallest index, like what is, so it is the like the first index, because set is storing in the ascending to descending order. So the first value is actually the one which I actually need, and that is storing on the smallest index. So I can just directly pop out the first value from the set. That is also very fast like action. So what you can directly see that this is some sort of building a model in which I can work upon and like design, like what design we can use. So that's all our logic here. Move on to the code part now, so I will understand, like you will understand it more really. So we have to store two things, like actually, so what we have stored here is this index mapping. Index mapping is storing out, and this is map. This map is storing out this integer to a set. This integer marks out what is the value. Okay, and then this set marks out like for a particular value where these, like in which containers it is stored. Okay, and this is one more thing I'll tell you when we go through the code. Like this is index map. So we clear the whole container, and then what we do here is that, let's say that we want to find out, like we want to find out at which position a particular number is present, like what is the first index. So what I'll do is I have the number, I'll search inside the map in which containers it is present. If it is empty, the container is empty, which means that it is present at no container, so I'll return -1. If it is present at some container, what I'll do, I will just take out the value at the very beginning and just like so this will return a particular pointer. I have to like dereference it and I will get the value out of it. So I will get the first value of the set and I can get it. That is the smallest value, that smallest index, that is fine. How I can update it out? For updating it out, what I actually need is, so if you just see is key, they will tell me that update this number. Okay, so for this particular number, update this particular index. So what I actually have to do is that I have to erase, like what I actually have to erase, I have to erase that this particular number is present inside the set. So for like in which set is present, my point is key, let's say they have given, what they have actually given in here is like change. In change they give the number, fill the container at index this with number this. So they actually tells us that in this index fill this number. Okay, so I have the containers, fill in 5th container, fill this number. but I have the mapping from number to container, but they want container to number. So I have to also store a reverse mapping, okay, from, so that I have a mapping in which I know ki like where this container is present, okay, because I want to change this container, like in which containers this is present. So what I'll do is that I have to also do a reverse mapping in which I will, if I give the particular number, like if I give this index, like particular index, it will give me in which number, like this this number is present at which index, okay. So I will get the number out of it. If I want to update in fifth container, I have a reverse mapping in which I will store that in fifth container 10 is present. So I will get the 10 from this mapping, and then from that mapping that I know 10, so I will go from that 10 to exact mapping from number to set, and in that set I will remove that index, okay, and then I will update ki now I want to update for this particular index this number. So I will update this as well as insert that number, because I want to insert this number inside that number set, okay, because that set is actually also holding out the container indexes. So I will also insert that. That's our logic. If you just like draw it out, it will become more clear to you, because this whole part is just the most complicated part here, because I have to also store the reverse index, because they want that in this index store this number, but I have the mapping from number to containers, but they want in this container store this. So I have to also store in which container which number is stored, because see, I have the mapping from number to containers, but they are like they want from container to number. So I have to also store the container to number mapping also. So if I store somehow container to number mapping, that is here in this container to number mapping index map, whenever they said change in fifth container, so I know in fifth container 10 is present. So if 10 is present, now I directly get 10. Now from 10 to set I have the mapping, that is this mapping, and then from that I can directly go to the set, do this, do whatever things we want, and also update in this map, because later on if you want to do one more like type of update, we have those reverse mapping also. That's the overall thing. So everything will comes down and boils down to the hang complexity. It will not run out of bound, or like time complexity error TLE. So that's overall logic and code part for all the 3 problems. I'll also make a video for the 4th problem as well, so stay tuned on this channel. If you still have any doubts, you can mention it in the comment box. Thank you for watching this video till the end. I will see you in the next one. Till I keep coding, and bye.